So in this video we'll look at conic sections, and in particular we're going to look at the parabola. Right, so what is a parabola? Well, if you take a line, let's call this line L in the xy plane, and you take a point, let's call that point F. Now you ask the following: find all the points xy, so let's put say over there our point xy. Right? We want to pick up points in the following way: that this distance is equal to that one. Right, so the distance between this point F, which we picked beforehand, and the distance to this line L, which we also picked beforehand, have to be equal. Right, so let's call this D1 and D2. Right. So here in this picture we've picked a very special line, right? A line y equals minus p, and a special point. The point F is 0p. Right, so let's see if we can find all the points for which these two are equal. Right, so D1 is supposed to be equal to D2. Right. Well, just to make the calculations a little simpler, we're going to ask that D1 squared is equal to D2 squared. That doesn't make any difference, because these distances are positive. So whether they are equal or whether their squares are equal, it's exactly the same thing. Right. So let's look at D1 squared. Well, it's going to be the x coordinate of this point xy minus the x coordinate of that point. So x minus 0 squared plus y minus p squared. Right. Multiplying it out gives us x squared plus y squared minus 2p y plus p squared. Right. Now if we calculate d2 squared, right, what's going to happen? Now remember, this distance, right, what we mean by that is we drop a line from xy perpendicular to this line L. Right, and then we calculate this distance. Right, so the point here on the line would be x is equal to x, right, because we're going down perpendicularly, and y is minus p. Right, so this d2 squared is going to be x minus x squared plus y plus p squared, and working that out, that gives you y squared plus 2py plus p squared. Right. So now if you put d1 squared equal to d2 squared, what do you get? Well, you get 4py is equal to x squared. Right. That is the equation of our parabola. Right. So this parabola is going to sit something like this. And so this line, right, we call the directrix. Right. And this point F is the focus of the parabola, and the turning point here we call the vertex. Right. So for a parabola, 4py is x squared, the vertex is at 0p, the directrix is y equals minus p. Notice that the vertex sits exactly halfway between the focus F and the directrix. Right, so in this case at 0, 0. Right. So now, if we look at this equation for that parabola, and we just switch around the positions of x and y. Right. So we look at 4px equals y squared. Right, then we also get a parabola, only this time its axis will be the x-axis. Right, so this parabola looks something like this. And its focus there at P0, and its directrix would be x equals minus p. Right, so again, this is the focus, and that line is the directrix. Okay. And this turning point is the vertex. Okay. So, in the case 4px equals y, it's exactly just x and y changing roles. Okay. Now all of the parabolas we're going to look at are going to be either of these two forms, just shifted horizontally and vertically. Right. And we'll look at some examples of that in a subsequent video.